Let's go through some review questions for Chapter 4. Here's question number 1. Which of the following are the terrestrial planets? Well, the terrestrial planets are those 4 planets that look like Earth, Terre, and they're within the asteroid belt. That is Mercury, Venus, Earth, and Mars. Answer C. Question 2. The major differences between the terrestrial and Jovian planets involve, well, the major difference is the mass. The mass of the Jovian planets are much greater than the terrestrial planets. Density as well. The volume of the Jovian planets are much greater than the terrestrial planets, but in terms of mass per volume, the density, they're a lot less because they have a lot more volume in proportion to their mass. They also are rotating faster. The Jovian planets rotate faster than the terrestrial planets, but that's on the order of hours, maybe 10 hours to 16 or 17 hours, and of course the Earth is 24 hours, so that's not as much a difference as the mass and the density. So we would say that the major difference would be the mass and the density. Which of the following defines density? Well, we just said it's mass per volume. It's how much matter you have per space. If you have more matter per space, then it's higher density. So density can be thought of as matter per space. Lots of matter in a small space would be higher density. The angular diameter of an object, well, Jupiter looks pretty small if you look at it. So, just by looking at it through a telescope, you wouldn't really know, unless you had other information, how big it actually was. And the problem is it's because it's so far away. As it gets so far away, its angular diameter gets smaller. So the angular diameter will decrease if the object is further away. Question 5. Compared with terrestrial planets, Jovian planets share all the following characteristics except, well, all the Jovian planets have low density compared with the terrestrial planets. The density of the Jovian planets are on the order of 1 or 2, which is on the order of ice or water ice or rocky ice, and the terrestrial planets are much more dense. Jovian planets all are a large size, much larger than the terrestrial planets. They have many moons. Every Jovian planet has at least 8 moons, and the Mars has 2 moons. So, in comparison, the terrestrial planet has the most moons. All the Jovian planets have ring systems around their equators. So the only thing they don't have is a slower rotation because they all are rotating faster than the terrestrial planets. Question 6. Pluto seems to be more similar to... Pluto is like a dirty, icy rock out there. Density right around 2, but not density because of gaseous type density, but more because it's like a Kuiper belt object, a comet type material. So it's more similar to the moons of the Jovian planets. It's more similar to icy worlds that would be around the Jovian planets. Most asteroids are found, asteroids being the rocky interplanetary debris found between Mars and Jupiter. There are some Earth-grazing asteroids that find their way inside that, but most of them are between the orbits of Mars and Jupiter. The asteroid belt is evidence of A planet that once orbited the Sun but later was destroyed. B, ancient material from the formation of the solar system. C, a collision between Jupiter and one of its larger moons. D, comets that were trapped by Jupiter's gravitational field. Probably A or B are your best bets. Because there's such diversity in the asteroid belt, it's unlikely that it was a planet that was later destroyed. It's possible, because of differentiation, that a planet was destroyed and had all these pieces that were different densities. But because of the true diversity, it probably was ancient material from the formation of the solar system. Question number 9. Compared to asteroids, comets show all these properties except, well, their orbits tend to be more elliptical as they come from the Kuiper belt or even from the Oort cloud. They're coming in with greater eccentricity in their orbits. They tend to be made of ice. That's true. They can look fuzzy because of outgassing. The average distance from the Sun is far greater, so all B, C, D, and E are true. Their densities are not higher. Asteroids are made out of rocky material. Comets made out of dirty ice, much less. So comets have densities much lower than the asteroids or the planets. Here's a nice picture of Comet Halley. What causes a meteor shower? Well, meteor showers occur at the same time every year as the Earth follows through in its orbit through a now defunct path of a comet. So as you go through the debris of an old comet that is in that orbit of the Earth, then it will fall down through the atmosphere of the Earth and you get a meteor shower. That's why they always occur at the same time every year. So the answer is Earth runs into the debris of an old comet littering its orbit. Question 11. Any theory of the origin of the solar system must explain all of these except, well, there's a lot of circumstantial evidence in the solar system that helps develop a theory of its origin. Let's look at these. A, the orbits of the planets are nearly circular and in the same plane. That definitely should be part of that theory, that the ecliptic plane is rather flat and the planets are going around in circular type orbits around the Sun. B, the direction of the planets orbit the Sun is opposite to the Sun's spin. Well, that's not true. The planets are going counterclockwise around the Sun, and the Sun is spinning in the same direction, and most of the planets spin in that same direction as well. It's all a remnant of what would be thought of as the solar nebula, all spinning in the same direction. So, the answer would have to be B. Planets do orbit in the same direction that the Sun spins. Question 12. The condensation sequence theory explains why. Condensation is an idea that dust particles would help accrete and form the planets. And as these planets are forming, the ones that are closer to the Sun and the greater heat would only retain the heavier elements, and the planets that are further away from the Sun would have greater gravity, less temperature, be able to retain the lighter elements. So this sequence theory would explain why the terrestrial planets are different from the Jovian planets. Question 13. Astronomers have detected most extrasolar planets by observing. Most of them to date have been observed, since you really can't see the planets, you look at the circumstantial evidence, and you look at the wobble. As the planet's going around its respective star, the star will wobble back and forth, and that will give a little bit of a Doppler effect on its spectroscopy. So the wobble of the parent stars using spectroscopy will help detect the extrasolar planets. Question 14. Extrasolar planets the size of Earth have not been seen yet with current techniques because, Actually, recently a Earth-sized object has been detected around a brown dwarf star, but most of the time it's really hard to do this because they're so far away. It's easier to see larger planets closer to the stars that are causing this wobble effect. Small planets are going to be really hard to detect. So it's just the fact that trying to look for them, it's just easier to see large planets. But it's not to say that there aren't many small planets out there. We just can't, it's hard to detect them. So the answer is D. That concludes this short quiz that should help you review for Chapter 4.